Welcome back to Launch Window Research. My name is Nathan Evans, and in this video I was fortunate enough to interview Adrià Argemí, the CEO of Pangea Aerospace. Recently, Pangea was successfully able to build and test an Aerospike engine. And in this video, we talk about how they pulled off this amazing feat, their plans for the future, and how far Aerospike technology could go. Also, only a small percentage of people who watch these videos are actually subscribed, so if you end up enjoying the video, please consider subscribing. I hope you enjoy. Adrià, it's great to have you with us today.
Thanks. Yeah, thanks, Nathan, for having me and being able to showcase a little bit what we're doing from here, from the other side of the Atlantic.
Yes, well, we're so glad that you could join us. And just a few brief questions, just in case anybody is not familiar with you. How old is Pangea Aerospace, and what is your guys' mission?
Okay, so we founded the company 4 years ago, in 2018. And we want to be the leaders into space hardware, reusable space hardware. We are really developing what we think is the next generation of launcher technology, starting with, of course, advanced propulsion, and then with reusable launchers, sorry.
Of course, and you guys have had a recent breakthrough with developing an Aerospike engine. Just in case anybody doesn't know, what is so advantageous about an Aerospike engine?
Absolutely. So Aerospike engines is not something new. It's not that we reinvented the wheel. It's a type of rocket engine that actually was researched extensively in the US in the late 60s, 70s with the whole Apollo era, or as many older engineers say, the good old days when they have much more money, at least public money at that time. So it's a type of rocket engine that optimally works always. What does it mean? Normally, that conventional rocket engines with this bell-shaped ones, they are designed to work perfectly at a certain altitude. With the Aerospike, the plume can really expand freely because it's only the ambient pressure that compresses the plume towards a spike in the center. So it really, as the rocket goes up, the plume expands, and so it can always work in optimal expansion. This translated into numbers could be more or less up to 15% more efficient. And what does this mean? So it's more payload that you could put into orbit with the same engine. And if you can put more payload, more money, more revenues for the potential client or launcher. So that is the reason why we are investing in this type of technology that nowadays, thanks to advanced manufacturing technique, is possible. Because when it was firstly investigated, as I said before, large public contracts with a multi-billion almost investment put it into there, where designing and manufacturing rocket engines was for sure. It was handmade one by one, the cooling channels and stuff. So it was super costly. And actually very challenging, because the Aerospike, one of the main challenges it has is thermal management, the cooling. Cooling it down, it's super complex. And for example, we solved it thanks to 3D printing. So 3D printing really enables you to have a design freedom that you can almost do whatever you want in terms of shapes and topology to actually solve that problem. So for us, it's advanced manufacturing that enable us to, let's say, as many call it, put the holy grail of propulsion, the Aerospike, and making it a reality.
Everything your company has done is really impressive. You touched on it a bit. The technology, originally wasn't ready back in the 60s when all this money was being poured into it. But you've been able to create a demonstrator engine that's roughly like 20 kilonewtons.
Yeah, tell you a little bit more about it if you want.
Yeah, of course.
So we've hot fire tested a 20 kilonewtons engine, completely 3D printed in only two pieces. So it's an annular Aerospike. So first piece on the annular, the shroud, the external shroud, an internal one with the plug or the spike. So only two pieces with actually a NASA-developed copper-based alloy called GRCOP 42. And we hot fire tested in the German Space Agency in late November 2021. And it was a great success, way better than we expected. We were there, of course, you never know with the new rocket engine. So the startup sequence was perfect on time. It ignited the first try, and we even ignited it a total of 9 times. So we want to test as well a little bit of reusability, a little bit of throttling. And one of the interesting things that we want to test as well, and it went super good, is that the regenerative cooling system that in our case is dual. How we solved the inherent problems with Aerospikes is that we are using both propellants to cool it down. So in our case, we are using methalox, so methane and liquid oxygen. We chose these propellants for technical reasons because methane doesn't produce any soot in the cooling channel, so it eases reusability. And of course, you can even think of biosource methane in order to make carbon neutral propulsion system. That is very important as we believe in really fostering a sustainable space. And yeah, we tested many times, as I just said. It was a success. Listening to it, whistling and roaring in the background, and almost 5 minutes in total cumulative flight time. And now we are working on our next design, of course.
Of course. That's incredibly impressive. And of course, I assume you're working on a much larger one now. When can we expect that, and how big are you going to make this engine?
So the next gen engine, or our first orbital engine, it's called ARCOS. It's a 300 kilonewton engine, so 30 tons of thrust, still methalox. We are, let's say, taking all the learnings and the good tips and tricks that we experienced during the demo P1, this demonstrator that we call this. We are not very good at naming demo P1 as demo for demonstrator and P for propulsion. So we want to make it fly by the end of 2024, beginning of 2025. So we want to have a first flight of an Aerospike, at least in history, at least that we know, commercial Aerospike by then. And yeah, we have a lot of challenges, as you can imagine. So still cooling it down with both propellants, introducing a cycle into it. So it's many things. As you go bigger, many other problems arise on the manufacturing side, and yeah, many others, I would say.
Yes, of course. I know a little bit about how the expander cycle, while you're using the hot gas to power the engine itself, solving two birds with one stone, it doesn't necessarily scale particularly well.
Okay, yeah, I can comment on that. The expander cycle for an Aerospike actually would be the perfect match if you have this dual system, in the sense that you are utilizing both propellants to cool it down, and then both propellants are expanding and getting hotter, and then you can expand them into separate turbopumps. However, for us, at the time being, we are not envisioning a closed cycle as a dual expander would be. We are more focusing into an open cycle, a simpler gas generator, even though because you could still do some smart tricks with the exhaust of the turbine to actually not lose that performance and put it in some specific places of an Aerospike to, let's say, retain better performance. But yes, our long term, of course, is to why not go for a dual expander, but we have to be realistic with the resources we have. We have a lot of ambition, of course, but we at least want to leave one foot on the ground.
Yes, of course. Definitely many aerospace companies have failed because they've gotten too ambitious too fast. So I'm very glad that your team is taking that into consideration. So, of course, you're not just building an engine. You have to build a rocket around the engine.
What I can tell here is it's actually a very interesting topic as well, because, we have to develop not only a rocket engine and a novel one, which you can... Actually, we started from a blank sheet of paper. There is almost no literature and flight data on how to do an orbital Aerospike. However, on the rocket part, there's a mission of building technology blocks. First, the engine, trying to even commercialize that engine to other launcher companies, to agencies, to countries, and then adding up like add-ons and like a Lego, putting a first stage that could be why not a booster stage for bigger launchers and reusable ones that you can, you want to gain a little bit of payload, I'm sticking my reusable booster to it. And then, of course, on the long term, adding an upper stage for, having the full solution. However, on this side, we are partnering with a lot of suppliers and partners on co-developing it, because we do believe that something is very interesting, pretty interesting is happening right now in the space sector in general, which is we see that it's not a very mature sector yet, in the sense that you can see, of course, the case of SpaceX that wanted to develop everything in-house when they first appeared, because it has the traditional industry was a little bit spoiled and biased on charging a lot of money to the public institutions and big grants. So it's like, okay, let's cut the cost, try to go faster. However, now with specialization, with many more people and actors willing to enter this market, we are seeing that there are much more interesting companies doing, I don't know, for example, avionics, that they do only avionics, or they do the tanks, or they do, I don't know, the TVCs, for example, for the engine, the thrust vectoring control systems. So why should we do everything in-house? Of course, I will have to integrate it all, which is still challenging, a very interesting engineering challenge. But from an economic point of view, and from also a funding point of view, if I have to compete with the Rocket Labs, Astras, Fireflies, I'll have to raise, 200 million euros or dollars minimum to do it all, to do the rocket engines, to do the stages, to do the avionics, the electronics, the launch pads. Of course, we have to, don't forget about the launch pad, which is a big chunk of money going down the sink into the infrastructure. So we believe that the best approach, now that it's populating more and more the sector, as many other sectors that are more mature, much more specialized companies will appear, and we want to be the integrators, like Boeing or Airbus. They don't do their airports, they don't have their airlines, they are not building their engines, so they are the system integrators. And they buy engines from, General Electric, and they integrate. So we want to be that reference into the hardware, space hardware, and we want to lease that hardware, we want to, be paid per flight because it's reusable, but I don't want to have to do everything in-house. So I think it's much more interesting in terms of funding. You need less funding. You can serve many other customers with an approach like this, because if we want to build a hardware and then I have a partner that operates it, for example, I'm not constrained by my own operations. Like, for example, Rocket Lab, they cannot launch more because they have to produce more electrons, and they have to have many more launch pads in order to, go up and down, now down as well, from now on. So we want to build this strong partnership and this supply chain in order to make for the MESO first stage, where we try the ARCOS engine in, I would say 2.5 years. So by the end of 2025, beginning 2025, making that flight. And that flight will be also the test flight for the first stage, and then working on an upper stage. And even on reusability first stage, and we are envisioning as well reusable upper stages as well, which is one thing very interesting, that Aerospike-like engines really allows you to even think of full reusability, which I do believe, or we do believe, it's going to be the main big thing in the future. I think everyone that is not working on reusable launching capabilities right now, our opinion is that it will be doomed sooner than later. Yeah.
Of course. Well, it's great to hear that you're working on the MESO rocket, not just the engine. But honestly, it's even better to hear that you're ready to share the Aerospike engine with the rest of the industry.
Yeah, absolutely.
I know that you're probably bound to not saying too much about this, but I have to ask, have any other companies reached out potentially using your Aerospike?
Yeah. The only thing that I can say is that commercial actors and agencies, like public actors, has reached us to actually ask, hey, what about this? Does it work? When can we make it fly? So yes.
Okay. Well, yeah, no, I didn't assume that you would be able to say too much about that. I assume we'll get a reveal in the coming months and years about who's interested in this Aerospike engine. But on your website, the MESO rocket, you have said have an interest in making it reusable. What contraption do you plan to implement to make it reusable?
Okay. Yeah, good question. Actually, let me also explain a little bit on why we do believe that reusability is key. And it's a mix always of a technical decision and also economic decision, because actually we are leaders in our consortium, in a public consortium, thanks to a European Commission public grant, and it's called RRTB project. And we are investigating reusability as a whole on how to land a first stage of a micro-launcher, what are the main challenges of a re-entry, because of course, I mean, it's super easy to say, yeah, go up, and then you say you have to go down, you are freaking fast, that thing gets hot. And also the economics, and this is important. So reusability is not like, oh yes, if I reuse, it's better. It's not that simple, unfortunately. So you have to take into account, of course, all the technical challenges, the payload penalty, because it doesn't come for free if you want to reuse. Also the logistics, where you're going to launch from, where you're going to recover it. It's going to be a barge, kind of SpaceX in the middle of nowhere in the sea. It's going to always return to the launch site. So taking everything into account, we still believe that reusability pays off. Our very conservative approach and calculation says that about 4 launches, it's worth it. And of course, much more than that, it's way, way better, because not only it decreases your cost, but it actually really fosters and augments your frequency of launch. So that's very interesting. Then on how we do it and how we want to do it for a micro launcher, or because it's where we want to start, we want to, of course, grow bigger in product portfolio and with bigger engine and bigger launcher, but we have to start somewhere. For micro launcher, it's very complex going the SpaceX way. So SpaceX way meaning, of course, going up, doing a boost back, going down, doing a re-entry burn, and a final retropropulsive landing with final burn, because the payload penalty there is pretty big. However, here once again, our technical decisions on why we went for an Aerospike, we're seeing that with the Aerospike, just thanks to its shape, it eases reusability, because the loads it can withstand are just better, and it smooths the way out. Of course, you are still re-entering something that doesn't want to re-enter and wants to burn and just buckle around, but it really eases, and you can even do a passive re-entry. So you are taking out of the equation one burn, actually the longest one. So this is less propellant that you have to take with you, that it's not paying you, because it's not putting payload into orbit. So we are now for a launch micro launcher taking into account propulsive landing. However, very challenging on the propulsion side, on the engine side, because you need deep throttability, and Aerospike plus deep throttability possible, yes, but complex as well. And why we are considering as well mid-air catch. It has been demonstrated now by Rocket Lab that it's possible, even though they drop it afterwards. But it's now, we have, a precedent. So someone has done it, so many other people can do it. And of course, for bigger launchers, then for sure, retropropulsive landing is not the only way to go, but we do believe it's the most interesting one.
Yes. And when it comes to building a bigger launcher, of course, the European space industry is significantly less mature. The space industry as a whole is not particularly mature, but particularly in Europe, I believe there are dozens of smaller launch companies planning on building these smaller rockets. Mm-hmm. And it'll be exciting to see when some of those merge and combine and build a larger company capable of building something larger, something that can take humans. So I have a few questions about that. When it comes to making, say, that longer-term closed-cycle Aerospike engine, how big do you think you could make it?
Yeah, I mean, as I said, we don't want to stop into the micro-launcher segment. We want to go bigger. To give you some order of magnitude, we are already doing some feasibility studies on how the technology scales up to the meganewton class. So, on the 100 tons of thrust. And actually, we're seeing that an Aerospike, the bigger you make it, the better it gets. The delta in performance gets bigger. Of course, not bigger and bigger infinitely, but it gets bigger. And then it helps you also on the re-entry purpose that I just explained. So it really gets a very interesting technology brick to actually have it in your, not only us in our portfolio, but to offer it to any potential customer or client. But yeah, I would say something interesting would be on the 3 meganewtons kind of class, so a little bit bigger than a Raptor.
A little bit bigger than a Raptor.
Yeah.
Roughly 3 meganewtons. And what kind of ISP or efficiency do you think you would be able to reach with something like that? I know this is a complete guess, speculation.
Yeah, it's a very difficult question, but the good thing with an Aerospike and Aerospikes with, let's say, on first stage, so atmospheric part of it, first stage's engines, is that you can have a very good expansion ratio. So very large expansion ratio. So you can, you don't have to care that much about your sea level ISP, because the whole point of an Aerospike that it works always perfect. So you have, for a first stage, you could reach 350, 360 seconds of ISP if you do it super big, because you can allow yourself a pretty big expansion ratio. So yeah, on the 350s for a first stage engine, that's on a vacuum ISP, that's incredibly good. And then of course, if you do a proper job on an upper stage, going into, this at the end, it will be limited by the propellants you chose. And with methane, there's unfortunately a chemical limit that you cannot surpass. But yeah, on the 360s, 370s seconds on an upper stage would be within reach. Yeah.
Of course, and an engine larger than the Raptor with an ISP of 360, 370 would be incredibly exciting. And when it comes to building a launcher that big, you could potentially build a fully rapidly reusable launch vehicle. But that would be a massive undertaking, and I'm assuming by then you would want to potentially team up with a few other companies. Yeah. Are there any other European companies that you've been talking with that you would consider?
Everyone. Yeah.
Everyone?
Yeah, absolutely. Here, as I said before, our business model and our approach is a little bit different in the sense that we really believe that we're working on the next generation of technology, because, and of course, our bet is the Aerospike. It really has a lot of potential and a lot of advantages, but we cannot go alone. I think the time of completely vertical integration has, a limit, and we are closer and closer of that limit. So we have to think on, okay, what a more mature industry would do. I put the example of aviation. The automotive is even more extreme, where not a single car manufacturer does almost anything. It's just buying from different suppliers and assembling it. So in that sense, of course, we try to talk to everyone, because we see that a lot of them are rushing to go to the market because the market is there and there is only some players acting. So it's still a blue ocean ahead of them. But we're working on the next generation technology, and we want to really offer, when we do arrive to markets, like, hey guys, you know how to launch rockets, you know how to operate it, you know how to commercialize them. Hey, you want to buy this? It's going to be much more efficient, because if you operate this rocket, that of course we can put all the logos you want in it. I don't care about that. You are gaining a little bit more of payload capacity, so more revenues for you. Now that you have all your skill sets and all your team to doing the operations, I'm building you the car. You make your Uber or taxi company.
Great. And one question I have to ask on behalf of my audience, because a lot of the people who watch this channel are space enthusiasts, but they're also very interested in investing in the space industry. So I'm curious, do you have any longer term plans of becoming a publicly traded company, or are there any ways that somebody watching this could potentially invest in Pangea in the future?
Okay, so yeah, of course, our founding team would like to see it all the way up to making an IPO. That would be a very an interesting problem to have, a very interesting story to tell later. So far we've always funded through VCs, and even at the very beginning we did even crowdfunding. That it's very uncommon, or was uncommon for, let's say, a space tech company or rocket company. So yeah, our goal would be to, why not, go into an IPO, and now we are currently fundraising our Series A through only private investors or VCs. Yeah.
More personally, what do you think is the most interesting part of space exploration and the role it plays in humanity's future?
I mean, I don't want to fall into the cliches, because I'm an aerospace engineer, so I have that techie, nerdy part of me pushing me like, oh, this is super cool. Now that I'm as CEO of Pangea, I'm doing a lot of other things rather than engineering. But I come back to my team, it's like, oh, guys, what are the issues we're having today? Can I, help on something? But personally, of course, what space exploration in general and space is giving us as humans is first that sense of how unique we are, and how it's a humbling effect as well. So we are unique, but we are so tiny. So we really have to have that ambition to go and reaching the stars, to actually understand why we're here, on where we are. There is anyone else there? So for me, of course, it's trying to understand as well humanity. And the perfect example would be that we need space assets to monitor Earth. So I think it's a quote of one of the Apollo's astronauts one time, or the first, I don't remember, I'm very bad with names, but I remember this quote. It was, we had to go to the moon to discover the Earth, which is as well one thing that many people forget. Oh, why we should spend so many millions into rockets and space tech? Because you need to go out there to actually monitor, control climate change issues. Now, for example, that Earth observation has become more and more important. Unfortunately, now with the war in Ukraine, you can control many assets, military assets from above. So it will be a more common thing, and I think we have to do a lot of work. And actually, guys like you with your channels are really doing a good job with that, on try to normalize space. Because of course there is this sentence, this is rocket science, super complicated. It is complicated, but hey, we're looking into the star. That's so cool, and we have to really encourage younger generations to look up, because it's looking up that you can solve many problems than looking down again. So I don't know, of course I'm biased because I'm working in the industry, but I'm super passionate, which is another interesting thing that you cannot find in all the sectors. I would say that 95% of the people of the sector that I talk to is like, oh, this is so cool. And then you talk to competitors, but at the end of the day, they are as passionate as you for, I don't know, rocket engines or rockets or space exploration in general. So it's a humbling effect, I would say, to look to the stars.
Yes, and I think you touched on exactly what drew me to the space industry, why I want to spend my life working in the industry, just because passion runs so deep in this industry. And you mentioned the effect that inspires the next generation. What would you say to the next generation of rocket scientists or engineers, if any of them are watching right now?
I mean, I would tell them to keep dreaming, because big things are coming. I mean, if the space sector is gonna increase just half of what all the reports says, it's gonna be amazing already. So there much more opportunities will arise, and even we cannot think about it. I mean, even the reusable rockets, when all of us heard of it the first time, SpaceX is going to try to reuse. Come on, no, that's nonsense. That's never going to work, blah, 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 blah. And look now, it's like, it's normal. So I think it's the most exciting times to be alive, because we don't know in 5 years from now, we will see, for example, Starship being a reality, much more players, the first Aerospike flying, ARCOS on our side. So I would tell them to, if they are inspired by it, to just enter into the sector, because it's an amazing sector, and also to everyone. And I want to make a special mention as well here to younger generation, especially on females as well, younger women and younger girls, that unfortunately is still a very male dominant industry, and of course everyone is welcome. So I think it's a very encouraging message to continue on pursuing the dream and willing to enter an amazing and history-making sector, I would say. Yeah.
Yes, well, that's cool. A lot of history will certainly be made in the next few decades, and I think you and Pangea are going to be a very massive part of it. So thank you for taking this time to join us today.
Yeah. Thank you, Nathan, for having me, and it's been a pleasure. So always here to update you on what we're doing.
Of course. And I have one more question. This might be a bit of a long shot, but just because people are going to be so curious about this closed cycle Aerospike engine that could be bigger than the Raptor, have you and your team theorized at all about what it's going to be called? Any potential name for this ultra powerful perfect
Not
engine?
at all. Not at all. To be completely honest, I mean, this is we're doing constantly feasibility study. We're working with some agencies here in Europe to actually how this could be scaled up, and notably with the French Space Agency. But no, we don't have a name. First, let's make our ARCOS flight, and then we will go for the next generation and bigger ones. Because already it's challenging at 30-ton ones. We're talking about 300 tons. Whoa, that's scary.
Well, yes, of course. Well, I know that after from Terran Space Academy, he's going to have lots of fun building a potential rocket around this engine.
Absolutely. We'll be glad to provide him with one.